Hi everyone, our next topic in continuing in Unit 2 is on type conversions. And this can be kind of a complicated topic, sort of as complicated as you want it to be. And what we're going to do is really focus on the cases that are going to be most important for us. And you can see a little bit more detailed explanation in the notes or in the documentation on like the CPP reference website that we link to a lot. So what are we talking about is changing between these types. So remember, what are the types that we have? We have C string, double, int, char, and bool. There are other types in C, but these are the only ones that we're going to be dealing with, at least for now. And when we talk about type conversions, we're going to take C string out of the picture, because that one's not a built-in type to the language, and so the compiler can't automatically do conversions with that one. So really we're just talking about these four types: double, int, char, and bool. And what we're going to be looking at is, first of all, like, when do they need to occur? And there's a few cases. The first case is what's called an explicit cast. That's when we actually ask for, please do this type conversion. The second case is when only one can fit. So when there's a circumstance when only one type could possibly work, then the compiler will try to force that in. And then the most complicated one is with operations. Like, let's say when you're adding two things of different types. So we'll first look at at that one. And then we'll look at the how. How does C actually do type conversions between these four different types? Okay, so the first place where we are going to see type conversions is with what's called an explicit cast. And this is where we tell the compiler to change from one type to the other. And actually, this word cast, I think, is a good one here if you think about it in terms of like a play. So it's if you're cast as a role to play Juliet in Shakespeare, then you are not actually changing into that person yourself. You're temporarily acting like Juliet for the purposes of that play, and then you go back to being your normal self. And it's the same thing is with explicit casting. We're just asking for like a temporary interpretation of that variable as a different type. So for example, if I have like double x equals 3.6. The way that I do an explicit cast is I have open parentheses and the name of the type I want to cast that into, like int, and then I put the value that I want to change. So this is saying change cast x from whatever it is into an int. And that will produce, in this case, it will actually produce 3. According to the rules that we'll see in a second. Okay, so that's the general thing for an explicit cast. Is we have a parenthesis, we have the type that we want, and then the original value, like this. And so we can apply this even for more complicated things other than a single variable. So for example, you could say, I want to cast as a char the value of true plus 36. And we'll see in a moment what all of that would mean, but it's going to compute this value, whatever that is, and then interpret that result as a char. Okay, so that's what an explicit cast is. That's kind of the simplest case of casting. The second case is when there only one type can fit. And this is the example that comes up most often when we're like assigning. So if I have, using the same example as before, x equals 3.6, I think is what I said. Then if I say int y equals x, what this is doing is this is going to cast x from its original type, in this case a double, into the type of int. So this is what's called an implicit cast. Implicit cast to int, But we didn't have to tell the compiler, please cast this like using the previous operator. The compiler knows that, well, this has to be an int since we're assigning to an int, and it'll do that cast on its own. Similarly, if I use a function, so if I say, for example, write num, like this, well, the write num function expects a double for this first argument. And we're not going to get an error here. Instead, what's going to happen is another implicit cast, where the compiler will try to cast whatever's here to the type of what is supposed to be there for the write num function. So in this case, it'll cast this false, which is a bool, into double, which is the type that write num expects. And then, so that's the second kind of casting that we'll see. And the third kind is when we have some arithmetic or some operations. And this is, as I mentioned, the most complicated situation of casting, but it's not that complicated because we are only dealing with a few different types. So remember, we have double, int, char, and bool. And they kind of are, I've ordered them specifically so that up here we have kind of the wider types. Remember, double is 64 bits, and int is 32 bits, char is 8 bits, and a bool, even though it's stored in 8 bits, is really just a 1 bit, a true or a false. So at the bottom we have things that are narrower. And so the rule is when we have for any operation, C doesn't know how to do any operations except on two things which are the same type. So the first thing that has to happen is they both have to be, both parts must be the same type. So if we try to do an operation between two things of two different types, the first thing that the compiler will do is try to cast them so they can be the same type. And then the second thing is that for arithmetic type operations, they both must be numeric types, which in our situation just means int or bool. Okay, so you can't add two chars directly. You could add two ints. And so what the compiler is going to do is try to go up in this direction from narrower to wider as far as it needs to be until it gets two, which can be the same type and with our both numeric types. And so what that means in practice is that if we have at least one of the operands as a double, then they'll both become double. Otherwise, both things will become ints. So for example, if I said the letter A divided by true, that seems bizarre. I don't know why we'd want to do that, but we can write that and that'll compile. And what does it mean? Well, A is a char and true is a bool. So we need to go up until we get to a point where they can both be the same and both be a numeric type. So what's going to happen is that they get cast up to an int. So this char will get transferred to an int, and this bool will become an int as well. And so the result of that division will be another int. In fact, whenever you do any arithmetic like on chars and bools or ints, the result is always going to be an int. Another example is if I said 3 times 1.1. Well, 3 is an int, and 1.1 is a double. So they're both numeric types, but they're not both the same type. So what direction is it going to go? It has to go up in this hierarchy. So that means that this 3 has to become a double. So this will become essentially the same as 3.0 times 1.1, which is going to equal 3.3 as a double. So that's the most complicated of these automatic type conversion rules that the compiler will try to do. But just remember that they both have to be, for most operations, they both have to be numeric, and for all operations, they both have to be the same type. So now that we know when these kind of conversions are going to happen, the next thing we want to ask is, how do they work? How do they work? Because these types are very different from each other. So the first thing is that we're going to, before any kind of type conversion is going to happen, we're going to interpret char or bool as numbers. Char or bool as numbers. So for char, what that means is the ASCII value. And if you Google like ASCII table, you'll find exactly an ASCII table. But let me show you how we can also get that directly from the command line. Is kind of cool. If I say man space ASCII, ASCII, then I get this convenient thing that I can scroll around in. This is what's the first example of what's called a man page, by the way. And you can see it's telling you a lot of things, but the normal decimal value is the second column. So for example, the capital letter D has a value of 68. A is 65. Capital A is 65. So that means that if I were to try to deal with the character D in a cast, that's equivalent to 68, for example. And you're not expected to memorize the ASCII table, so if you need to know that, we would give you access to it. But just know that every character can be interpreted as some number in the range of 0 up through 127. And for bool, you should know this already, that false is 0 and true is interpreted as 1. So that's the first thing we have to do is, if we're doing any kind of type conversion, we need to think of chars and bools as numbers, either the ASCII value or 0, 1 for bool. And then we again think about this hierarchy of double being the widest at the top, then int, then char, then bool. So in this direction, going from a narrower type to a wider type, going to a wider type, it just is going to maintain the same value. Just maintain the same value. Right, so for example, D as a char, if I were to cast that to a double, well, that is going to maintain its same value of 68, and just as a double, it'll be 68.0. Okay, so we interpreted that as an int, and then we think about what that means. If I were to cast the Boolean value of false to an int, well, false is 0, so that would just become the int value of 0. So going to a wider type is kind of straightforward. And then in the other direction, going narrower, like in the top to bottom direction here, is usually going to be truncation. So let's see some examples of what that means. So if I convert a double to anything, it's just going to drop the floating point. If I say what happens if I cast 6.8 from a double to an int, that's just going to give me 6. Because it's truncating, it's just dropping off everything after the decimal point. If I want to interpret a large integer value as a char, it's actually going to convert it down into the range of chars. So usually you don't want to do that, but if you wanted to for some reason, you could. And yeah, so when this is for going narrower, that's if we wanted to go from a double down to an int. If we go from an int down to a char, I mean, if the int is small already, so like we saw that 65 is a capital A, then this would totally work. We just say take this int value of 65, interpret that as a char, and we get a capital A. If you put some bigger number here, which is outside of the ASCII range, then it'll turn it into some character, actually according to mod 256. But usually that's a bad idea and probably not what you want. And then the only exception there is bool. Bool is special, so it has special rules. But the rule for bool, now I want to come with some kind of the rule for bool is cool unless you're a fool. I don't know. So the rule for bool is that anything that's 0 becomes false, and anything else becomes true. So what would be the conversion if I cast 0.3 to a bool? Well, 0.3 is not equal to 0, so that would become true. What would happen if I cast the character for 7? So this is a char now. If I cast that to a bool, well, that's not the null character, so it has a non-zero ASCII value, so that would become true. But of course, if I said, what is the bool value of 3 over 5? Ooh, now this is getting a little tricky. We have to think about first, this operation is the int value of 3 divided by the int value of 5, so that does integer division rounding down. So that's now the bool value of 0. This would become false. Okay, so generally when we're going up from a smaller type to a bigger type. It just maintains the same numeric value. When we're going down from a bigger type to a smaller type, usually it's going to be by truncation, just to fit into that smaller type, like dropping the decimal point. Notice that it doesn't round to the nearest int, it just drops it off. Except if we're going to bool, then it's just anything which is exactly 0 in the original type becomes false. Anything which is not exactly 0 in the original type becomes true. And that's all you need to know about casts.